Okay, this is lesson 73, 21, 25, 27, 29. So if you had trouble with any of those, this is the video for you. So let's start out with 21. Graph on a number line. -6 is less than or equal to x is less than or equal to 3. The domain is just the integers. That means they're whole numbers, negative and positive whole numbers. So all it's saying is we want all the numbers between -6, so -5, -4, -3, -2, -1, 0, 1, 2, 3. And we're just supposed to fill in all the numbers of x that lie in between -6 and 3. This is seriously bad for. So and it includes it's and equal to. It has the and equal to sign right there, so it's going to include 6 and 3. So we're just going to put -6, -6, -5, -4, -3, -2, 1, 0, 1, 2, 3, and that is it. That's how you do 21. Okay, let's move on. 21, 25. This one says use substitution to solve. We have n sub p plus n sub n equals 175, and we have n sub p plus 5n sub n equals 475. I might need my calculator for this one. Okay, substitution. That means you're going to pick one of these variables, this np, this nn, this np, or this 5nn, this nn, and we have to get it alone, and then we're going to do some substitution. So it doesn't matter which variable you choose. I don't know, let's just pick this one. So I'm going to get this guy by itself, which means I have to bring that over there. You don't just pick it up and bring it over there, you subtract it from both sides. So we're going to get n sub p equals 175 minus n sub n. Now we're going to substitute. That's, you have to do this one by substitution. Elimination looks really easy, but they say substitution. So we're going to put what n sub p is equal to in for where the n sub p is, which is right there. So here we go. So n sub p is 175 minus n sub n. So see that instead of n sub p, we put what n sub p is equal to, plus 5n sub n equals 475. Combine our n's, so we get 175 plus 4n, whoops, let's go to 4. I'm going to add these two together. We have -1n sub n and 5n sub n, which would be 4n sub n equals 475. Then we subtract 175 from both sides, so we get 4n. Now what I'm doing is I'm subtracting 175 from both sides, so 75s will go away, and we're going to get 300. And finally we divide both sides by 4, so we get n sub n equals, 4 goes into 37 times, and then we have 20 left, 4 goes into 25 times, so we get n sub n equals 75. And then all we have to do is go back up into this equation, pick another color. We're going to take this, 75, and we're going to go up to, this equation works just fine. And where that is, we're going to put a 75. So we're going to say n sub p, let's do that over here, n sub p plus, instead of n sub n, we're going to put the 75, equals 175. And we're going to get n sub p equals 100. So make sure you get 2 answers there for that. My little pen isn't working too well today. Okay, let's just get 27 done on this video. I don't know if I can fit anything else on here. So 27 is simplify 3 times the square root of 125 Let's see, minus 2 square root of 45 minus square root of 50,000. That's looking intimidating, doesn't it? 50,000. So what we did was we learned to find the biggest perfect square that divides evenly into these numbers under the radical. So we're going to get 3. The biggest perfect square that goes into 125 evenly, I do believe, is 25. 25 times what gives you 125? That would be 5. So here's our perfect square. Here's what's left. Biggest perfect square that goes into 45 is 9. 9 times what gives you 45? That would be 5. And here's our big number one. Count our zeros. 1, 2, 3, 4. So we know that it's going to be a perfect square. So we're going to have 5 times 10,000 because we need to have, whoops, we need to have 4 zeros for it to be a perfect square, and it has 4 zeros. So 10,000. Should have put those in order. So all we did so far is we took each of these numbers and we divided into the biggest perfect square and what's left. Flip these two backwards. Then we're gonna just take these perfect squares and we're going to take the square root of them. So I'm going to go up here. So we're going to get 3 times 5 square root of 5 because the square root of 25 is 5 minus 2 times 3 square root of 5. Starting to have a pattern here, aren't we? Minus, we have 4 zeros, so that means we're going to have half as many zeros come out. So it's 100 square root of 5. That'll give us 15 square root of 5 minus 6 square root of 5 minus 10 square root, 100 square root of 5. And we're just going to subtract those out and see what we get. I hope I got the right answer for this. I didn't check the answers for any of these. So we get 15 minus 6 minus 100 is minus 91 square root of 5. I'm sure someone will tell me if I got the wrong answer there. Okay, let's see. I really have no time left here, but let me see if I can get the last one in. I have to pick up now with the last one. Just run this over here. Just put it right here. Let's get 29 done. 29 is a cool problem. It's a solve. It's an old type of problem. 2 times minus 3 minus k on that side. And then on the other side is minus 4 times minus 3 minus the absolute value of minus 3, that's 23, times k. Alright, inside out is how we work. So we're going to leave the minus out there. You can either change this, since we're getting rid of the parentheses, you could change this to parentheses or leave it as a bracket. So we're going to get minus 6 plus 2, minus 2k. This is all just being as careful as you can be. This is going to be 12 minus, now remember the absolute value of a negative is a positive, so it's just 3k. Now we're going to distribute this negative sign, so we get 6 minus 2k plus 2k. Remember, plus negative times negative is positive, negative times negative is positive, equals 12 minus 3k. K is on one side, numbers on the other. I'm going to add 3k to both sides. I'm not going to show all this work because you guys eventually need to not put that step in. I'm going to add 3k to 2k and get 5k. If I add 3k to negative 3k's, I don't have any k's. And I'm going to subtract 6 from 12, and we'll get 6. And hopefully the answer is k equals 6 over 5. Alright, that's all your problems, Chris. I hope you watched this. Alright, that's it.